Now that we have gone through the introductions, we're going to preview our unit. This unit, we're going to be learning about exponents. And exponents, you probably learned from last year, are basically numbers to kind of shorten and abbreviate words. Kind of like if we, let's say, live in the state of South Carolina. Instead of writing out South Carolina and spelling it out SOUTHCAROLINA, we just abbreviate it to say SC. Exponents are kind of the same thing. So when we look at exponents, we're looking at shortening it, kind of like using initials. Can you think of initials we use in school to shorten words? Sometimes when we shorten numbers, we learn this with addition and multiplication. We multiply, let's say, two numbers together in order to get an answer. So 2 times 2 is 4. It's kind of the same thing with exponents. We shorten the 2 times 2 and we actually make a base of 2, and their exponent would be 2 because we're multiplying 2 twice. So let's take a look at some definitions before we jump into that. Okay? When we have powers of 10, they are numbers that can be written as product of tens. Draw my text box here so you can see it. And as I'm filling this out, you can fill this out on your paper too. So for example, if I'm doing powers of 10, and this would be the probably simplest way to teach, is let's look at the number 100. Or we can say 100 is 10 times 10, right? Or let's look at 1,000. For example, we can say that is the same thing as 10 times 10 times 10. And those are our powers of 10. Oops. And so on and so forth. I can say 10,000 would equal 10 times 10 times 10 times 10. Notice that these zeros here at the end of your tens is equal to the amount of zeros that are in your actual product of your number. So here you have 1, 2, 3 zeros. 1,000 also has 1, 2, 3 zeros. So that's an easy way to remember your products of 10. So if I were to say I had 100,000, what would that equal? You are correct if you said 10 times 10 times 10 times 10 times 10 times 10. Okay, again, there are, whoops, let's see, 1, 2, 3, 4, 5. I got an extra 10 in there. Okay, so you have 1, 2, 3, 4, 5 tens over here. And over here we have 1, 2, 3, 4, 5 zeros. That's how we can check ourselves to make sure we're doing it right. Okay, let's take a look at what the exponent is. All right, your exponent is the raised number in a power. So let's write that down. That's the little small number at the top. It tells you how many times you have to multiply the base by itself. So let's take a look at an example. Alright, so I have 5. I'm going to bring that down just a little bit so you can kind of see what my exponent looks like to the 3rd power, and I'm going to make this an exponent. So it's going to be a smaller number above that 5. Okay, so I have 5 to the 3rd power. My 3 is my exponent. Again, it's this number at the top. Okay, let's take a look at our base. That's going to be the number in a power that is multiplied by itself. Alright, so in this 5 to the 3rd power, I'm going to write that again. The 5 is the base. Again, I'm going to make that an exponent. So we have our exponent, which is that 3, and our base, which is that 5. Okay? Now we're going to look at inverse operations. Last year, we learned that inverse operations are operations that undo each other. So subtraction undoes addition. Division undoes multiplication, vice versa. So it's any operation that undo each other. Kind of unwraps it and takes it apart for us. So for example, multiplication and division are inverse operations of each other. Okay, so we built our vocabulary. We follow these directions up here. So below were some terms that we've used before in other math lessons. If you know them, write the meaning and provide the example. And we did that. If you don't know them, we talked about what the meaning is and what the example is. So we used what we learned from the past in order to create the meaning and the example. So now let's connect to the real world here, okay? Let's think about a small space, like on a computer chip, okay? It is 0.00000035, okay? So let's write that down. So let's talk about a computer chip. Okay, equals 0, write it with me, 0, 0, 0, 0, 0, 0, 0, 3, 5. I know that's a lot of zeros. Okay, that can equal the same as multiplying our exponents. So we can say we'll use that solid whole number of 3 and 5. So we'll say it's 3.5. We're using our powers of 10, okay, times 10. And if we look at our decimal, we can move it over 1 to get that 3.5, 2, 3, 4, 5, 6, 7, 8 times. If we're moving it over 8 times, we're going to put it to the negative 8th power because we're making our decimal a whole number now. So we're going to make it to the 8th power. Okay? 3.5 times 10 to the negative 8th power is the same thing, except it's just written in scientific notation. A short way to write long numbers. So when we learn about scientific notation in this unit, this is what scientific notation is. That's what it's going to look like. let's take a look at the last part and look at our concept development. So let's talk about what we already know. Okay? Complete the concept map with information you know about exponential expressions. You may preview the unit 1 to find details to add if you wish, then talk with a partner. Since we don't have partners, we're just going to talk ourselves through this. All right? So let's take some time right now and think about what we know about exponents. Preview everything that we've talked about up here with our terms and down here where we connect it to the real world. What do you think an exponential expression is? You can say something like an expression, and there's no wrong answer here. An exponent is an expression, just like what we learned about last year with variables and constants, except exponents include a power. Okay, what did we know about it from just previewing the unit and what we saw up at the top? We know that a power is a base number with an exponent. We learned that it can just be the power or the power and other numbers and operations. We also learned that it can have variables as well, just like our previous units that we've learned in 6th and 7th grade with expressions. So give me some examples down here. And once you are finished, you can submit. I'll give you some of my examples and you're going to make up your own. So I can say something like 10 to the 3rd power. I can also say that it can be 10 to the 3rd power plus 5 to the 2nd power minus 6. That is also an expression. Okay? I can also say they have variables, just like we've learned in all other expressions. So I can say x to the 2nd power plus x. Or they can also be fractions. So I can say it's x to the 2nd power over 5 plus 1. So in this unit, we're going to discover different types of fractions, different types of expressions. So these are all examples of what exponential expressions should be like. All right, once you put in your examples of exponential expressions down here, you can save it and upload it to submit it.